Hey, Calc students, here's a secret technique of integration that your teachers will not tell you, okay? Here it is. Guess. That's right, guess. So what I mean is, if you're trying to find an antiderivative, guess a function, take the derivative, and see if it works, because we are much, much, much better at finding derivatives than we are at finding antiderivatives. You've been doing derivatives for all of calculus so far. We're really good at it. Antiderivatives are harder to do. Our brain doesn't quite work that way, so it's much better to guess. All right, let me show you what I mean. Here's an example. Let's take the integral of log of x dx. Now, what I'm suggesting is guess to what you think the antiderivative should be, and then we'll take the derivative and check. And now here's the key to making a good guess. It should be wrong. If your first guess is right, you took too long coming up with your first guess. We want to guess something, take the derivative, find out that's wrong, and then make the appropriate adjustment. So here's my first guess. It'll be a great guess because it'll be a wrong guess. I'm going to guess the antiderivative of log x is log x. Let me take the derivative. Oh, I was wrong. I got 1 over x. But that's great. That's fine. It's a first guess. It's a wrong guess. Now I can make an adjustment. Here's my new guess, which should be a little bit better, but probably still wrong. X times log x. The intuition is, well, a product rule will at least give me a log x as one of the terms, and then we can figure out the rest. The derivative of that is 1 times log x plus x times 1 over x. Ooh, that gives me log x plus 1. I'm pretty close now. I'm only off by a constant. That's an easy fix. So I'm going to say my third guess, x log x minus x. The derivative of that is log x plus 1, and then the derivative of the negative x is going to give me negative 1. Those cancel out, and I get log x. So I've found an antiderivative. An antiderivative, general antiderivative. Add that plus c, and that's it. And that's how it works. So you don't have to worry about u substitution or integration by parts, figuring out who's u and who's v. You don't need to do any of that. You just want to guess, take a derivative, and see if it matches up. And if it does, great. And if it doesn't, great. Make an adjustment and try to fix it and make it better next time. Which, to be clear, is how every advancement in human history has ever worked. We tried something, it failed, we made an adjustment, and we tried again. No one has ever been right the first time. Don't try to make your guess right the first time, but try something. Take a derivative, and again, because we're better at taking derivatives than antiderivatives. All right, you give it a try on your next integral and see if it works. Good luck.